Okay, we've looked at the graph of sine, cosine, tangent. Now we're ready to look at cotangent. And just as we did with all the other three trig functions, we're going to start with the unit circle and make some observations from the unit circle to see if we can figure out what the graph of cotangent looks like. Now remember, cotangent is the ratio of cosine to sine. Cotangent is equal to cosine over sine. Now recognizing that gives us some insight into what the graph might look like. For example, notice that if you consider pi over 2 and 3 pi over 2, in both of these places we have that cosine is 0 there. Now that tells us this. That tells us that the graph of cotangent is going to be 0 there as well. So we know this, that every place you see pi over 2, 3 pi over 2, or any coterminal angle to those two angles, you're going to have 0. You're going to have cotangent crossing the horizontal axis. So we could say, for all angles, pi over 2 plus any integer multiple of pi added on to it, that's where we're going to have cotangent being 0. So pi over 2 plus any integer multiple of pi. Now another thing we want to observe is at 0, pi, and 2 pi, in those places sine is equal to 0. Now that's significant because cotangent is cosine over sine, and if sine is 0, cotangent is undefined at that point. So we see here that cotangent is going to be undefined at any multiple of pi. 0, pi, 2 pi, 3 pi. You can see any coterminal angle to 0, 2 pi, or pi will give us something that's undefined. So let's see if we can put this information together and figure out what the graph of cotangent looks like. And I'm going to look at the interval from negative pi to pi. Remember that that's where asymptotes occur. Asymptotes for cotangent will occur at 0, negative pi, pi, 2 pi, all the multiples of pi. And I'll go ahead and draw the asymptotes there. Now we also have at negative pi over 2 and pi over 2, that's where we have the graph of cotangent crossing the x-axis, the horizontal axis. Now you'll notice this, that if you look at how this graph is going to behave, of course it's going to be asymptotic at x equals, or theta equals negative pi, theta equals 0, theta equals pi. It's going to be asymptotic at those places. It's going to cross the axis at negative pi over 2 and pi over 2. What we want to decide is, how does the graph look? In other words, does it look like tangent, where it starts from the left, passes through the root, and then continues up asymptotic to the asymptote on the right? Or does it do something else? Well, notice that between negative pi over 2 and negative pi, we're in the third quadrant. And in that quadrant, both sine and cosine are negative. So cotangent will be positive, since it's the ratio. So clearly that we can see that between negative pi over 2 and negative pi, we're going to have a positive value for cotangent. On the other hand, between negative pi over 2 and 0, well, that's in the fourth quadrant. And in that quadrant, cosine is positive, but sine is negative. So we're going to have the graph below the axis there, because cotangent is negative there. Now, over here between 0 and pi over 2, that's in the first quadrant, where both are positive. Well, sine and cosine both are positive. So cotangent is going to be positive. Between pi over 2 and pi, that's in the second quadrant where sine is positive and cosine is negative. So cotangent will be negative there. So the graph would look like this, decreasing from the left to right. Unlike tangent, remember tangent increases as we move from the left to right, we increase. Now just some things we want to know. First of all, the domain. The domain is all real numbers except theta cannot equal any multiple of pi. You can see there's asymptotes at all the multiples of pi. So theta cannot equal a multiple of pi. Now the range, of course, is going to be negative infinity to infinity. And the period. Notice the period is just going to be pi because you can see that the graph of cotangent does everything it's going to do between its asymptotes. And its asymptotes are pi units apart.